Hi, and welcome to the 7th episode in the Sienna training series. I'm Kate Doubleday, and I'll be talking about how to define cost data in Sienna data. Sienna is an open source ecosystem for power system modeling, simulation, and optimization with 3 applications. Sienna data focuses on efficient intake and use of energy systems input data, and that's what we'll be focusing on today. Sienna Ops enables system scheduling simulations by formulating and solving optimization problems, including the ability to formulate sequential problems for production cost modeling. So while we'll be focusing on inputting data into Sienna data, we're really intending to use that within Sienna Ops. The third application is Sienna Dyne, which enables system transient analysis, including small signal stability and full system dynamic simulations. Each of these 3 applications is built on a combination of packages in the Julia programming language. So today we'll be focusing on Sienna data and specifically inputting data using PowerSystems.jl. For existing users, it's important to know that what we'll be talking about today are updated cost functions that are available in PowerSystems.jl version 4.0 onwards. So if you used a previous version, you'll see that the structures are significantly different in most cases now. So what is cost data used for? We're focusing here on inputting the necessary data to enable production cost modeling, or PCM, in Sienna Ops. Production cost modeling is focused on optimizing the generating units in a system to meet the expected demand with the minimal total system cost. So there are 2 ways that we can input that data in Sienna. The first is in production cost per unit for each unit. And so that's answering the question, what does it cost to run each unit? That can include fixed costs, variable costs, as well as technology-specific costs. This is particularly useful to model vertically integrated systems where the system operator knows all of that information. It can also be used to estimate costs in markets where market bids are unavailable, but where you can make some estimate about typical heat rates or generating cost for certain types of units. However, if you're in a market system, a better option, if it's available, is to formulate cost data in terms of the market bids themselves. So this is focused on how much is a market participant willing to buy or sell power for. It includes their own calculation of their production cost, but also what profit margin they're aiming for. So this enables more realistic production cost modeling in market systems if you have that historical market data available, or if you're a system operator and you have the bids themselves. So within Sienna, there are 6 different operational costs structures available. The first 5 of which are more the production cost model. So for each technology class, thermal, renewable storage, hydro, and loads, there are typically fixed and variable costs available to model, as well as certain technology-specific costs, such as the thermal startup shutdown cost, renewable curtailment, and various storage costs. So sometimes the fixed cost is already represented in how you represent the variable cost. So there's a lot of flexibility in formulating things based on the data that you have. The last option is the market bid cost. And again, that's focused on modeling buy and sell offers. It's important to note that right now the market bid cost is a little bit in flux, so there might be some changes to the structure within PowerSystems.jl in the fall of 2024. So it's also important to know that these buy and sell offer curves can be input as a time series if you have that varying over time. Most of these costs are pretty straightforward to input. It's either a number or ratio, but the variable costs in particular can be quite complex, and they can have a variety of different units. So it could include a dependency on a fuel cost. So it might include a heat rate curve. It could also have a dependency on water flow or a transition to or from some other fuel or storage chemical. So in Sienna, once you've selected one of these 6 operational costs to best represent the unit that you're attaching it to, The next step is to also select a structure to represent the variable cost itself. This is a two-stage process. The first is to choose a variable cost curve based on the units of the data that you have. There are two options in Sienna: a cost curve, which is best representing data that's already in currency. So for example, dollars per megawatt hour or dollars per megawatt operating points. The second option is a fuel curve. So this is useful in cases where you have variable cost data, such as a heat rate curve that's in terms of fuel or water, liters of hydrogen, something else that's not currency. And in addition to putting in that data, you must also include a conversion factor to currency. And that could be a time series. So if you have a time series of gas prices, you could input that into a fuel curve. Both of these two options have two data fields: a function describing the variable cost data, and additional proportional variable operations and maintenance costs, which is typically in units of dollars per megawatt hour. So this first part contains a function that is just a unitless function describing that variable cost data. So each of these two structures, cost curve and fuel curve, are wrappers around what we call a value curve. So the second step in defining your variable cost is to choose a value curve that matches your variable cost function. This is just a unitless function, and we'll show the examples in a moment. But based on how you define your fuel curve and cost curve, that will define what the units are on the X and Y axis of this function. So check out the documentation. By default, the X-axis is defined in what we call natural units, which is usually megawatts, but it could also be in per unit values. Currently, we have 5 different value curve options in Sienna. They are shown here, assuming that they'll be wrapped in one of those cost curves. So the units here are defined in currency, assuming that each curve here is then input into a cost curve. So the options include a linear curve, quadratic data, and then 3 piecewise linear curves. So that includes a piecewise point curve where you have data of the cost at individual operating points, piecewise incremental curve where you have information on the slope between certain operating points, and piecewise average curves where you have the average rate itself at different operating points. So in defining a cost, there are these 3 choices to make: what the overall structure is, what variable cost structure you'll use, either a cost curve or a fuel curve, and then finally, what function you'll use to describe that data. And when you get to actually defining a cost, you'll do it in that reverse order. So you'll start by defining a value curve, which is just here the unitless data. In this case, we have a linear curve. And that becomes an input to a fuel curve or cost curve. So here we've inputted into a cost curve, and so our units are in currency. And you also have the option to add that additional proportional variable operations and maintenance cost. This whole set of data becomes an input then into your operational cost. So for example, here we're using a hydro generation cost, and that data becomes input into the variable cost, in addition to whatever other cost fields are included in that structure. So for next steps, if you're interested in walking through these steps for your own data, see Add an Operating Cost in the PowerSystems.jl documentation for a walkthrough of those steps and references to the various cost structure options. Thank you very much, and we'll see you in the next video.